Hey all, today we're going to talk about some special segments and lines that we will see interacting with triangles, and what that means about angles formed, and also about what happens to the sides of the triangles. So one category of segments or lines would be lines or segments that bisect a side of a triangle. Remember that bisecting means that we're going to cut a segment into two congruent parts. We also can cut an angle into two congruent parts. So the first one here, an angle bisector. This segment right here is an angle bisector. It cuts angle M into two smaller congruent parts. So we know that those two angles are congruent to each other. They have the same measure. Here, this median, it starts at a vertex and it goes to the midpoint of a side. So the midpoint of IK, which means that the two smaller parts of segment IK are congruent to each other. And in this one, I have a perpendicular bisector. It's a line. It's just going to go through the midpoint of one of the sides, which means that the two smaller pieces of AC are congruent to each other. So what we end up having here when we have either an angle bisector, a median, or a perpendicular bisector, we end up having either an angle or a side in the triangle that gets cut in half into two smaller congruent pieces. We also have a couple segments that end up being perpendicular to a side. One of them is called an altitude. So this segment we call an altitude. It starts at one of the vertices and it's perpendicular to one of the sides. So you see here that segment MP is an altitude and it's perpendicular to the side LN. So it's important to know that those two segments form 90-degree angles. So both of those angles are 90 degrees. Same thing here. We already talked about perpendicular bisectors cutting a side in half into two smaller congruent segments, but it also, since it's perpendicular, forms 90-degree angles. So again, we have more 90-degree angles here. So perpendicular bisectors actually do two things: cuts a side into two congruent smaller pieces and forms 90-degree angles. And we can use all this information, and of course we're going to apply some algebra to it. So here's an example. I'm telling you that segment BD, that guy right there, is a median. So that means that, well, first of all, we need to determine what that means. And what it means for a median is it goes to the midpoint of a side. And so that means that segment AD is congruent to segment DC. We want to find x if we know that AD is x plus 3 and DC is 2x minus 17. So again, knowing that this was a median, I know that D is the midpoint of that side, so the two smaller pieces should be equal to each other. And I can solve for x. I'll subtract x from both sides. I'll add 17 to both sides. And I get x to be 20. So I was able to write that equation, x plus 3 equals 2x minus 17, because BD was a median. And that told me that AC was cut in half into two congruent segments, AD and DC. So I want you to try this one. I'm telling you that segment MS is an altitude. So go back a couple slides if you need to and figure out what it means to be an altitude and what special information that tells you, and find x if a measure of angle MSQ is 7x plus 1. So because we know that MS is an altitude, we know that these are 90-degree angles. And I'm looking to find x, and I'm told that MSQ, which is this angle, is 7x plus 1. Well, we know that MSQ is 90 degrees because MS, segment MS, is an altitude, and it makes 90-degree angles. So I can say that this 7x plus 1 is equal to 90 degrees because they both represent the same angle. And now I can just solve this for x. I'll subtract 1, and I will divide by 7. We might get something that's a little messy. So I had to pause there and do a little calculation. So we get a decimal. It's a little messy. It's about 12.7. So in these types of problems, we're determining what it means to have a specific type of segment, whether it's a median, an altitude, an angle bisector, a perpendicular bisector. We're figuring out what that means, whether we have congruent segments or 90-degree angles, and then we can set up and solve equations based on that. So I have one you-do for you. You're dealing with an angle bisector, so make sure you first determine what that tells you about this problem. Then you'll be able to set up an equation and solve for x. Do as much as you can. You should have something. You should have an attempt here. We need to try this, and I will certainly go over the answer in class.